Alright, good morning class. Right, so today we continue for chapter 5.1, right? So chapter 4 I will teach in the class, right? Next week, if like when you finish your oral exam, okay? So today we go 5.1, that is a thermionic emissions, right? That we learn about electron. Okay, so explain the thermionic emissions and also the cathode rays. So what is the process of thermionic emissions? What does it involve? Okay, so we will look at that, okay, in this topic. Right, so explain the thermionic emissions. So the surface of metal, right, so they contains a large amount of free electrons. Okay, so what are free electrons? So the metal consists of a large number of electrons which are free to move. Okay, so at the room temperature, okay, so the electrons are free to move, but it still remain, okay, inside the metal. But when it gains energy, right, so let's say you give the heat energy to the electron, so the electron will move faster. Okay, so then after that there will be release. Okay, they will be released out from the metal. Okay, so the electron cannot escape at the surface because they are held back by the attractive force of the atomic nucleus. Okay, so this one I think you learned in chemistry, right? So there are metals inside, the free electrons inside the metal, okay, but in the room temperature they still remain inside the metal, right? But then when we heat it, let's say we heat the metal, then it gains enough energy, okay, so it will be released, okay, to the surrounding. Okay, what happened to the energy of the electron if the metal is heated? So of course the energy will be increased. Okay, and what happened to the free electrons if the metal heated at high temperature? So high temperature means you give the heat energy to the electron. So the electron will gain sufficient energy to escape from the metal. Okay, and what is the name of this process of electron emission? We call it as the thermionic emissions. So what does it mean by thermionic emissions? So thermionic emissions is the emissions of the electrons from the surface of heated metal. Must have the word heated metal because the electron will not release, okay, if there is no energy being supplied to the electrons. Okay, so the thermionic emission is the emission of electrons from the surface of the heated metal. So if they ask you what does it mean by thermionic emission, so this is the meaning, okay, emissions of electron from the surface of heated metal. Okay, so next we see what actually happened. Okay, what will happen to the electrons emitted if an anode is placed in the vacuum tube? Okay, so you already know, of course, electron is a negative charge, right? So it's a negative charge. So if you put the anode, right, you put the anode inside the vacuum tube. So what does it mean by vacuum tube? Means there is no air inside. So means the electron can freely to move, okay, without losing any energy, right? So here, when you try to move from here to me, wait for a moment, okay. So this is the electron, right? This is the metal. So we hit the metal, right? And then it will release electron. So the electron is a negative charge, while the anode is a positive charge. And you already know opposite charge, they will attract each other, right? So this electron will be attracted to the anode. So the electron will be accelerated to the anode, okay, because of the opposite charge, right? Okay, the next part. What is a vacuum tube? So it consists of a tungsten filament. So this one we already discussed in the electrics, right? Electricity that we know that tungsten, it can produce heat energy, right? Because they have the high resistance, so it can produce the heat energy, and also you must have a cathode and also anode. Okay, so the filament is connected to a 6-volt power supply. So means it doesn't need a high voltage. Okay, so state the correct terminal connection for anode and also cathode. So the cathode, of course, because this one is a negative, right? So it should be connected to the negative terminal. Okay. And then for the anode, right? So this is the anode. Okay. So this is the anode. You can see it's connected to the positive, right? It's connected to the positive terminal of the high voltage DC power supply. Okay, so the cathode will be connected to the negative terminal and the anode will be connected to the positive terminal. So you can see actually like this one, right? So this is a negative, it's connected here, right? And this one is connected back here. Okay. Right, what happened to the milli-emitter? So milli-emitter means it's like times 10 power of negative 3. So let's say if you got reading 2, right? So means 2 times 10 power of negative 3. So you need to be very careful whether what type of emitter that you use. Okay, so pointer, if you click the 6 volt power supply switch S1. Okay, so that means no deflection. Okay, no deflection. If you click the 6 volt power supply, so it means this one. Okay, there is no deflection. Okay, what does this indicate? So means there is no current flows, because even that it's just like the electron being released, right? It's just like electron being released. Okay, but there is no movement. Okay, so no current flows. But then what happened if we click both switch S1 and also S2, right? When we click both S1 and also S2, the pointer of the milliampere, milliampere is deflect. So why is it deflect? So it shows that the current flows. So the current flows means what? Because this one is just now this one is not function, right? Okay, this one is mean the positive part. So this one is not switched on. So means the electron will not move to the anode, right? Because it's still switched off. But then when you switch on the both power supply, right? Then what will happen here? This one will become positive charge. This one will become anode, right? And this one, the electron, you already know that the different charge, opposite charge will attract each other. So the electron will be attracted to the anode. So I mean there is a change, right? There is a movement, right? So means there is a current flows. Actually, the current flows because of the flow of electrons, right? So means if the electrons is flowing, means there will be a current. So explain your answer in question 6, right? So when switch S1 is closed, okay, so this one, okay, it's closed. It's closed mean this you mean that switch on, right? So you need to remember, not closed means switch off, right? Switch S1 is closed, it mean we switch on the circuit, okay, but there is a current flows, okay, but there is said when the switch S1 is open, that means there is no current flows. Okay, so you don't be confused, right? Because I know like we already said macam kalau dalam bahasa Melayu kita cakap tutup lampu, tutup means close, right? So tutup means the current is not flowing, right? So you cannot be confused, because S1 means you close, so you close means the switch, right? Take it down like that. Okay, you push it down like that, right? So means the current flows, but if the switch is open means the current is not flowing. Okay, so when switch S1 is closed, current flows and heats up the the filament. So mean at this part, the thermionic emission process will happen. Okay, so the electron will be released, right? So the electron are emitted because of the thermionic process, right? So and then high potential difference between cathode and anode cause electrons to accelerate to anodes. Okay, so because there is high potential difference between cathode and anode. So what does it mean by the potential difference? It's actually the energy that we use, okay, the energy that we use to move, right, from to move 1 coulomb, right, 1 coulomb of charge from point A to point B, right? So means there is a high potential difference, high energy between cathode and anode. Okay, so cause the electrons to accelerate to anodes. So it will be accelerated. So when the electron reach the anode, the circuit is complete and the current flows. So when the current flows to the anode, right? So when the current flows through the anode means the circuit is already complete. So the milli emitter will show the reading. Okay, but let's say just now if we just switch as on as one, right? So there will be no flowing of electron because at this part there is no high potential difference, or means there is no, this one is like no charge. So no charge means the electron will not be attracted to that way. Okay, so the circuit is complete and the current is flow. So this one is the explanation. Okay, who knows, maybe this one, right, they ask you to explain why the milli emitter, right, got reading. Okay, so this is four marks, right, usually. So explain cathode rays. What will happen to the milli emitter pointer when the connection is reversed? So let's say just now we put the anode, right? The anode to the anode here, and then we put cathode here, right? So the pointer does not deflect. Just now the cathode is at this part, the anode is at this part, but now we switch, okay? And then the electrons are emitted when the filament is heated, right? So means this one, the filament still be heated, but they will not attracted to the cathode, which is also negative charge, right? So mean if this one, right, if this one, there's still the electrons still be released, right? Because they hit the tungsten filament here. So of course, the electron will still be released, right? But it will not attracted to the cathode because the cathode is also negative charge, right? So it will negative charge. So the negative and negative usually we already know is repel, right? So it's repel each other. So they will not attract to cathode. So mean there will not be current flows, right? Because the electron is not be transferred, okay, at this part. Okay, so the circuit is not complete. Okay, so mean this part you have to know, you have to make it a cathode, and this one have to make it anode, right? Then the milli emitter will be deflected. And if you switch it, you make it the opposite, right? So there will be no electron, right, be moved because the negative is repel. They will repel each other. Okay, so thermionic emissions occurs when electrons have enough energy to escape from the surface of heated cathode. Okay, so mean they must have enough energy to escape, right? So where they got the energy is come from the electrical energy. Okay, and the cathode ray is a high speed electron beam. Okay, so mean it's very high speed. Okay, so we call the electron flowing, okay, the electron flowing, we call it as the cathode rays, right? So the electron flowing from the cathode to anode, we call it as the cathode rays, okay, and has a high speed electron. Okay, so when the cathode is connected to an anode by a high tension power supply, EHT, okay, so a beam of electron is accelerated to anode. So this one we just discussed just now, right? So when the cathode, you connected it to the anode, right, by a high power tension supply, EHT. So you can produce the high potential difference here, right? So mean the electron will move, okay, with the high acceleration, okay, to the anode, okay. Okay, so thermionic emission and the production of cathode rays in a vacuum tube. So explain cathode rays. So the first one is an electron gun. So this diagram, right, we call it as the electron gun, okay, electron gun. So what is an electron gun? So it's actually a vacuum tube to produce a cathode rays. It means it's the produce to it's a apparatus, right? Apparatus to produce the cathode rays, means the electron, okay, electron rays, because cathode you already know it produce the electron, right? So a vacuum tube means, so inside this one is a vacuum. So why is the space in the electron gun is vacuum? So there will be no collisions between the electrons with air molecules, because if there is a collision, of course there will be energy being used, right? So we don't want the energy being used. So and also no ionization occurs. So inside the air, they got the air molecule that sometimes they have a charge, right? So electron have a charge, then maybe they will charge the they will charge the air molecule there, right? So we don't want that one. So that's why they have to put it in the vacuum tube. Okay, so working principle of electron gun. Okay, so they're available each part of it. Okay, so the first one, all right, of course we need to have the 6 volt. So AU is actually AC, alternating current, right? AU is actually in Malay arus ulang alik, but in English we call it as the alternating current. So means the alternating current is the one that we use in our home, is actually the alternating current. Okay, so 6 volt alternating current. Okay, what does it do? Is heat up the filament. So what is inside the filament? Right, it's the tungsten, right, and it will heat up the cathode to release the electron. Okay, so the filament or cathode, right? So it emits electrons after being heated with the process of thermionic emissions. Okay, so filament or cathode emits electron after being heated. So after it being heated by the electricity, by the electric energy, right? So there we have enough energy, and energy will be converted to heat, right? Then after that, they will release the electron, right? After the electron gain enough of energy, right, to release from the surface of metal. Okay, then after that, we have another one, right? So we have another one, you call it as the extra high tensions. So what does it do? Is actually produce high potential difference. Okay, it means high potential difference means high energy, right? Because we already know the meaning of potential energy. Potential difference is energy that being used, right, to transfer 1 coulomb of charge from one point to another point. So means that if you said high potential energy means high energy. So at this part, okay, so at this part it have high potential difference between cathode and anode. Okay, to accelerate electron to anode. So why did they have to have the high potential difference at this part? Okay, so this one is because of we need to accelerate electrons to anode. Okay, we need to move it faster. Okay, so we can produce the high speed beam of electrons. Okay, so this is the part that they have the high potential difference. Okay, then we see the another one is the anode. So what does the anode do? So the anode accelerate electrons from cathode, because you already know just now opposite charge they will attract each other, right? Okay, and the high potential difference is actually to help the electron to increase the velocity, or means to accelerate. Okay, right, so the anode accelerate electrons from the cathode. Okay, and then you can see there is a pendaflow screen. What does it do? So since the electron, okay, which being released, right, from the cathode, so it goes to the anode, right? So when it hits when you move, it has a kinetic energy. Okay, so when we start to move from the cathode to the anode, so it has a kinetic energy. But when it hit to the pendaflow screen, right, the kinetic energy will turn to the light energy. Okay, so I just show you the sequence of the energy being transferred. We started from here, right? So the first one is electric energy. So then the electric energy is converted to heat energy, right? So then the electron absorb the heat energy, right? Then it gains enough energy, then it released to the surrounding. So this happened at this side. So then the electron is already released at this part. So it needs to move because the anode is a opposite charge. So it will move to the anode with the high acceleration. So when it start moving, of course, you already know everything that move must have the kinetic energy. So this one, they have a kinetic energy. So after being kinetic energy, then after he hit the floor screen, so that heat energy will turn to the light energy. So that is the function of the pendaflow screen. It converts the kinetic energy of the electron when it's moved to become light energy. So you will see like a dot or something, and sometimes they put it like a cross there. Okay, so you can see there is a light, right? There is a shadow there. That one we will see that one after Maltese cross, right? That one is later. Okay, so cathode ray can be used in a picture tube of a television, C.R.O. Okay, this one you already learned, I think, during Form 3. Okay, cathode ray oscilloscope, C.R.O. And also the visual display on the radar screen. Okay, so now we already know what is actually thermionic emissions and how does the electron, right? How does the electron it move? Okay, it move inside the cathode rays. Okay, so means you know already there is a electron, there is a metal there, right? We hit the metal, it release the electron, then the electron will move to the anode with the high acceleration. Okay, and then after that it hits the pendulum screen, then the pendulum screen return the kinetic energy to the light energy. So that is actually how does it function for cathode ray. And what is the thermionic emissions? You already know that one. So now we see explain the effect of the cathode rays in electric field and magnetic fields. Okay, does it deflect? Does it show any deflection, or they don't have any deflection? They didn't move at all. So we will see that one. Okay, in this topic. So this is actually the cathode ray. Alright, this is actually the cathode rays, right? So then we have the Maltese cross tube. This one I already mentioned just now. Okay, this is the deflection tube. Okay, we have the Maltese cross tube, and then we have the deflection tube. Okay, the one that have the X deflection and also Y deflection. The characteristic of the cathode ray can be studied by using a Maltese cross tube and also deflecting tube. So I mean the characteristic. What is the characteristic of cathode ray? Right? Whether it's react with the magnetic field or not, or is it move in the straight line? Okay, so we see that one. Okay, investigate the properties of electron streams in a Maltese cross cathode ray tube. So this is the apparatus, Maltese cross tube. So this one is come from the cathode ray, but we add a Maltese cross tube here. Okay, we add the Maltese cross tube here, but this one, the apparatus is the same as the cathode ray just now. Just we add the Maltese cross here. Okay, then after that, so this is the procedure. We don't have this one at the lab. I'm sorry, because this one is quite expensive. Maybe they got, but I don't know. Like I think it's too old already. I don't think that it can be used, right? Our lab need very, like a lot of new apparatus. Okay, but this one we don't have. Okay, and you already know that your amali, right? Your amali, we need a lot of money. Okay, to buy the apparatus, which is we don't know what apparatus come out, so we need to save that money. Like last year, until I have to borrow from other subject, the budget for the other subject like PJK, borrow their money, to buy the things for the amali, because they use a lot, like quite a lot of expensive stuff like voltmeter, ammeter cost you like RM 80 ringgit. So we have how many students, right? So that's the problem. So it's hard for, like for the teachers to buy, like this kind of expensive stuff, because we need to think for your amali at the end of the year. That's more important. But we try to our best, right, to show you maybe by video, or maybe you can go to another school. There's another school that still the apparatus that still one can be used. Okay, so I will show you a video later, right? So a procedure, 6 volt, right? So 6 volt heater supply is connected. So this one is actually for the filament, right? So what happened here? The observation, a shadow of cross is seen. Yellow light is produced on the screen. So what is the explanation by if we have that kind of observation? So the shadow is formed. Okay, so the shadow is formed because light from the heated filament is blocked by the Maltese cross, right? So why does we see the cross here? So it's because, right, the light from heated element, okay, so you already know the light, you convert it to the light, right? So when it hit the pendulum screen, right, it return the kinetic energy to the light energy. But this one at this part, okay, the electron is being blocked. Okay, so it means the electron cannot pass through because they got the Maltese cross there. So it means at this part it become dark. Okay, but at this part it can become yellow light. Why? Okay, because the electron can pass through and it can convert the light energy, the kinetic energy to light energy. But this one it being blocked. Okay, so what is the conclusion that we can make? So light travels in straight line, or we can say the cathode ray is travels in the straight line. The electron is travel in the straight line, because they say if it's not straight line, right? So maybe they can, deflected here, then go at the back, right? But this one no, right? That means it's travel in the straight line. Okay, so then another thing is a 6-volt heater supply and 3 kilovolt power supply is connected. Okay, just now we only switch on this part, right? We only switch on this part. Now we switch on S1 and also S2. Okay, what will happen? So the observation, a dark shadow of Maltese cross is surrounded by green light. Just now yellow light, right? Now it become green light. So a dark shadow of the Maltese cross is surrounded by green light. So what is the explanation? Why it become green? Right, okay, so it says here the electrons emitted are accelerated to anode and to screen. Okay, so the electron emitted, right, from the cathode, okay, it will be accelerated to anode and to screen. Okay, so the shadow, okay, the shadow is formed by the cathode rays blocked by the cross. So the cathode rays travel in a straight line and can cause fluorescence effect. Okay, that means it become green because of the fluorescent effect. Right, so this one also will shows that the cathode ray also they move in the straight line, the same as the light energy. Okay, so we conclude here, travel in a straight line, cause fluorescence, and the cathode ray carry kinetic energy, which is converted to light energy when they hit the screen. So this is actually the experiment. This is called as the Maltese cross, okay, and this is called as the cathode rays, right? Okay, maybe we can see this video. No, another one. Sorry. Yes.
Assalamualaikum rakan guru yang saya hormati sekalian. Di sini saya ingin berkongsi.
Yeah, I'm not sure. Maybe you cannot hear the voice, but it's okay. We just want to see the effect. So this is the cathode rays, okay, and you can see there's a fluorescent screen here, right?
Ini adalah tiup palang Maltese. Sebenarnya ada palang di tengah-tengah ni.
See the Maltese cross.
Ada palang ni. Screen kena flow.
Fluorescent screen.
Tiup palang Maltese ni masih mengekalkan.
So you can see they put it into the first one by the power supply 6-volt, right? And then another one is using the EHT. Okay, so the EHT will be connected, right? See the connection there.
Sambungan kita ni pada 12 volt.
But this one they use a 12 volt. So if you want to increase the acceleration, you increase the voltage. When you increase the voltage, okay, what will happen? I mean, they have more energy, right? So means more energy, they will move faster. Okay. Right. So this one you can see the voltage supply is connected at this part, because inside this they got the filament. So the filament will be heated, then release the electron.
Secara random lah.
Okay, so you see there is a cross tube here. Okay, so this part.
Bagi kita lebih jelas, pecutkan elektron daripada cathode ke sini. So untuk pecutkan elektronnya daripada cathode ke anode ni, kita wujudkan high voltage.
So cathode to anode, they must have the high voltage.
Yang kita gunakan EHT. Voltage voltan lampau tinggi ni. Kita sambungkan.
Okay, so what happened just now is when they didn't connect the S2, they connected S1 only, mean at this part. So you can see there is a green, light, the yellow light, right, produced.
Bayang hijau terbentuk.
Okay.
Naikkan, nampak? Oh, tak buka lagi. Oh, okay.
See,
Okay.
Now after you switch on S2, okay, the pendulum floor screen become green. right? It becomes
So,
green.
buka
So when you switch off the S2, you only switch S1, mean at this part only you switch on. Okay, you can see there is a yellow light. So mean only electrons, right, will be flowing. Okay, but then after that, you switch on the S2, okay, means the anode.
So elektron tadi akan
So that can
melanggar,
produce the
palang,
green
kan.
light
Bila
energy.
elektron ni melanggar palang, so menyebabkan skrin kat sini, kat sini berubah bentuk. Ada cas sikit sini. So melanggar palang. Okay, perlu tak mainan apa lagi?
See, right, this one I want you to see.
Palang mantis.
Okay,
So bila
so what happen if you put a magnet,
ni akan menunjukkan
right, a
palang.
permanent magnet? Okay, what will happen to the shadow? Okay, what happened to the shadow?
Kecil lah. Dia pun bahaya pada pelajar.
Okay, so you see there is a deflection, right? It moving.
Kita lihat palang ni. Ini ada kebocoran current ni.
Okay,
Ada kebocoran current ni. Okay, bila kita lekatkan dengan magnet,
okay, when you put a
dia akan
magnet,
bergerak ke bawah.
it will move downward.
Bagaimana dia bergerak ke bawah dan ke atas, kita kena tahu hukum tangan
Okay,
kiri.
so how do we know,
Kalau
right?
elektron dia
How do we know that it will move upward or downward? Okay, so that one is by using the Fleming left hand rule.
daripada cathode ke anode, berarti arus
Okay,
balik lah.
later
Arus
that one we
daripada
learn in
anode
chapter
kepada
4. I will
So ini
teach you.
pengaliran arus dari hantu.
See, the teacher shows the
so,
Fleming left hand rule. I think this one you already learned, right? From it's in form 3 or form 2, I don't remember. I think form 2
ke selatan, kan?
by the electromagnetism. See?
Arus ke
Okay,
dalam.
wait, I just go back because I want to see the hand actually. Using the teacher's hand.
Arus ke selatan. Ini arus ke dalam.
Okay. Alright. So how do we use the Fleming left hand rule? Okay. So here is force. It shows force. Okay. And this is the magnetic fields. Okay. Is north and south. Okay. So this is the force. Means if they show this part like this, the thumb going downward means the force is downward. If the thumb going upward like that, okay, like the one which you good one at, that one the thumb go up means that one the force is going up. Okay, but this one the force is going down. Okay, so north south. Okay, north south. Okay, so at the end of your fingers there, this is north. Okay, here is south. Okay, then the third one, the third fingers, right? It shows the current flows. Which way the current flows? We already know the electron is flowing at this way, right? So means if the current flows from this way, the electric current is flowing the opposite way, like this. Because they say we label the direction of the current, right? We always say that current must be from positive to negative, right? Even we know that actually the current is the flow of electron, must be the negative, right? That means the negative to positive. But actually, for this one, because the electron is moved at this way, so means the current is moved in the opposite way. So it going that way. So that's why the I, you see the teacher's hand there, the third fingers, it move, okay, on that way, okay, at this way. Okay, then after that, this is the magnet. So they say this is not, right? This is south. So they just use that one. Okay. Later I will teach you how to use the Fleming left hand rule. Oh my god. Okay, oops.
Assalamualaikum. Sebaliknya lah. Arus
Okay, so you can see it going downward, right? Just now when you deflect when you use the magnet, you can see they move downward like that. So how they know? Because by using the Fleming left hand rule. Okay, utara, selatan, north, south, and this is the current.
Arus ke dalam So magnetnya daripada utara ke selatan. So untuk tangan kiri filament, so dia akan bergerak ke bawah.
See, it move downward,
Ini
right?
pernah ditanya dalam soalan SPM berkaitan dengan tube paramasis, kenapa bayangan ni bergerak ke bawah.
Only the shadow lah is going downward.
Ini
Okay.
perkongsian dia begini. So ini adalah selatan, dia akan bergerak ke bawah. Dia akan bergerak ke atas lah. Dia bergerak ke atas. Okay. Ini perkongsian daripada saya.
Okay. So that's the video. Okay, so let's move to the next part. Okay, so this is the do the experiment inside the lab. This is a boarding school lah. Okay, this is a boarding school lah. So usually they have a lot of, you know, all this type of equipment they will have. See? See? So you move upward this one. Now they switch, the current still flow at the, it move like the outward, right, at that way. Okay, the current still move that way, but now they change the magnetic fields, so you have to switch, right? You have to turn your fingers there, the second fingers for the north and south. Okay, so never mind this one, we see later with the class. Okay, how to use the Fleming left hand rule. All right, so we move to the next part. So investigate the properties of electron stream in a multi-cross cathode ray tube. Okay, so this one we already see how the teacher do the experiment, right? So what is the rule that being used to use the deflection of the shadow by using the Fleming left hand rule? Okay, so remember the electron, even the electron move from here to here, right? But the current is moved, okay, at the opposite way. Okay, and also you have to see this is north and south. Okay, so means you need to put your fingers like upward like that. Okay, north south. Okay, and the currency is going to the left, right? It's here, means to the left. Okay, then you see your fingers is going at what way? Move from the magnetic field, move from north to south, right? And then the current to the left, opposite from electrons. Okay, then your shadows will move to B. Okay, so you can try, right? You can try. Okay, so your eye should be, your third fingers should be goes to the left, right? And you're not south. I already label for you, right? The fingers, it must be north and south. So north and south. Okay, the current goes that way, then it move to B, right? So mean this one is correct. Okay, so remember for this one, okay, I will show you in the class next week, if like, because I don't know like what's your time, during what time your lesson, because not every day, right, you got lesson. Okay, this is another example. Okay, so shadow move downward. Okay, this one I show later in the class lah. Okay, deflecting tube. Okay, now the first thing, all right, the first one we have the cathode rays, right? That means they have the anode, the cathode, right? And then we have the filaments there. Okay, and then we add, after that one is after that we add multis cross. Okay, then we add multis cross. Then we add the pendaflor screen, right? Or we put the pendaflor screen there. Okay, then we put another one inside of the cathode ray. We have the deflecting tubes. So maybe we add one by one component. Okay, so remember the first one, cathode ray only got filaments, cathode, anode. Okay, and yeah, only that, right? okay, and then we put it in the high velocity, EHT, right? Then that one connected to 6 volt or 12 volt, depends whether you want it to have the high accelerations. Okay, and then after that we put the Martis cross and also the Pendaflow screen. Okay, the fluorescent screen. Then we put it there. Okay, so then we investigate. Yeah, it move in the straight line. It can be deflected by the magnetic. They will be deflected in magnetic fields. Okay, and we know which way they go by using a Fleming left hand rule. Okay, now we add another component. That is a deflecting tube. Okay, investigate the properties of the cathode rays in electric field by using a deflecting cathode ray tube. Okay, so when you connect the 6 volt AC, the alternating current power supply, and you connect the anode and cathode to the EHT1 power supply. So now we're trying to change the connections, right? We try to change the connections. So here we have the EHT, we connected it to, because they have two plates actually. Okay, so they can the deflecting, right? The deflecting tube, they have two plate. So one plate we connected it to the positive, and another one we connected it to the negative. Okay, so you can see here that at this part, okay, they connected it to what? To the positive. Okay, so to the positive means this part they have the positive plate. Okay, then below here is a negative, right? So it connected to the negative part of the power supply. So this one is have the negative plate. Okay, then we try to switch on. We switch on. This one not yet. We say to connect to the 6 volt power supply. Okay, and connect the anode and cathode to AHT1 power supply. So we still not switch on yet. You can see the switch is still open, right? The switch is still open. So means there is no current flow. So means there is no deflection. There is just only like the cathode rays travel in the straight line. Okay, but then so this is the experiment. Okay, so maybe it's better you can see this one so it can be more clearly. Oops.
Assalamualaikum. Di sini saya
So I just fast forward.
The magnet agak pan. Kemudian pada filament dulu kita wujudkan sambung kat sini. Kita dapati ada nyalan pilihan.
Yeah.
Okay, ada nyalan warna hijau.
So you see there is a straight line, not that clear. Okay.
Nampak ada
Because there is a light
hijau.
there. So you can see it moves straight line.
Warna biru.
Okay, it moves in the straight line. I mean this one is not switched on, right? So it will move in straight line. But then after that we switch on, you can see it bends, right? It bends downwards. It's actually depend where do you put the positive and the negative. Let's say this one you put it at the negative, and this one you put it at the positive. Okay, so it will reflect to here. But let's say we switch, right? We put the positive here and the negative here, so it will deflect upward like that. Okay, because the electron is a negative, right? So it will be attracted to the it will be deflected to the opposite charge, right? I don't know what happened.
Assalamualaikum.
Cannot move to the next slide. Okay, so this one I think much clearer. Yeah, the cathode ray move in a straight line. This is like okay. Right. Then after that, okay, we investigate, right? We investigate the properties of cathode rays in electric field by using a deflecting cathode ray tube. So just now we can see no deflections, right? So it move a straight line. Okay. Then we connect the 6 volt AC power supply and connect the anode and the cathode to EHT1 and EHT2 power supply. So we they use two EHT. Okay. So what happened here? Okay. So the positive, let's say this one, they put the positive plate above and the negative plate below. Okay, so you can see it deflect to positive. Why? Because cathode is the electron and the electron is a negative charge. Of course, it will be attracted to the positive plate. So it will bend towards the positive plate. Okay. So if they bend to the positive plate, what can we conclude there? So we can conclude that the cathode ray is a negative charge, right? And also it can be deflected by the electric field because you already know the currents, like even like you put the positive and negative charge, there will be a current flows, right? There will be the electric field. That's my pen. Yeah. Like this. Okay. Positive, negative. Okay. So positive going out, negative go in. So there will be an electric charge here, right? Electric field, not electric charge. Electric field here, right? So it can be deflected by the electric field produced by the plate. Okay. So that's why the cathode ray deflects in electric fields and negatively charged. So we can conclude that it can deflect in the electric field, magnetic fields, and also actually it has a negative charge. Because why? Because you can see it bends toward the positive plate. Okay, maybe I don't know what happened. Cannot move to the next slide without seeing the video. Okay, now they put cathode pada cathode, anode pada anode. See, it's bent. So if this way, it means what? This one is a positive and this one is a negative. This one is already they connected to the positive A part and this one they connected to the negative, right? Okay, now they change, right? They change. They said repeat the experiment by connecting top plate to the V negative EST2 and lower part is connected to the positive terminal. So what happened? So the path trace is still parabola but is deflected downward. Okay, so this is the video. Okay, just now. See it going downward because they changed the terminal. Now they put it we put a magnet. See, there will be deflection. So there's a deflection. See? Lah. Okay. Nice experiment, right? Okay, so next we see the conclusion of the cathode rays. Travel in the straight line in vacuum, of course, possess kinetic energy or momentum. Of course, when there is a kinetic energy, means they have a V, right? Because kinetic energy is half mv square, right? Okay, so that means they have the velocity. So once they have a velocity, of course, they have the momentum because momentum is mv, right? So mv, that's they possess of kinetic energy and the momentum. Why? Because they have the velocity there, right? Okay, and this is a negative charge. We already proved it bend towards the positive plate, deflected by the magnetic fields and also electric fields. We already learned that one by using the Maltese cross, right? Remember, we used a Maltese cross just now. Okay, and then we put a magnet, then it move downward, upward, and how we know which direction it move? By using the Fleming left hand rule. Okay, and electric field just now also using this band, right? Means inside the positive negative charge also, you know there's a electric field between the positive and the negative. Okay, so you can see just now the teacher, right? They put the magnetic fields there and it move. Okay, so it be deflected. Okay, and then they produce the fluorescent effect. Okay, that means the kinetic energy convert to light when it hits the screen. there is a conversion of energy that I already explained from the electric energy, all right, and then to the heat energy, then to kinetic energy, right? Then it transforms to the light energy. So you must know the transformation of energy starting from the electric energy. Okay, how to determine the velocity? Okay, so this one is actually all right. This is the formula. Because we assume, right, because this is in the vacuum, right, so means there will be no lost energy. So what is actually EV? EV is the electron energy. Okay, so electron energy, then after that it will gain the kinetic energy, that half mv square. So it will we will accelerate that to maximum velocity. So the kinetic energy will change to the light and heat energy when it hit the screen. So this is the conversion. So the electrical energy E is equals to EV. Okay, what is actually E? E is actually the charge of electron. Okay, then it goes to the kinetic energy, then it goes to the heat and also light energy. Okay, so this is the formula. Okay, E is the small letter E is actually the charge of electron is 1.6 times 10 power of negative 19. V is the potential difference across the cathode and anode. Just now, right, I already told you, right, there is a voltage, there must be high potential difference here, right, to help the electron to move faster. Okay, it's going from cathode to anode, right? And then after that, applying the principle of conservation of energy. Okay, so we assume that the electrical energy is same as the kinetic energy. So EV is equals to half mv square. Okay, and E is the charge of electron, V is the potential difference, okay, and then M is the mass of electron, okay, and V square is actually the velocity, maximum velocity of an electron. Okay, so this is the formula. Okay, so this one we already discussed. So how we use it? So depends. All right, what is the question? If they ask you to find the speed, okay, means you need to find the the V here. But usually they will ask you to find V, of course, the velocity. Why? Because E is actually the constant value, right? I mean that 1.6 times 10 power of negative 19. V is the voltage, the potential difference across the anode and the cathode. Okay, and M is the mass of electron, which is constant also, 9.1 times 10 power of negative 31, right? So it means the V is actually the one that we need to find. So usually they ask you to find V. So you just substitute the value given. Okay, like this one, right? They give you a voltage is 4,500. Okay, so means here you just replace it with 4,500. E, you already have the value, right? It's a constant, half. And then the mass of electron also is a constant. So mean you need to find your V square here. Okay, so you just arrange back your formula. Okay, and you can find the answer here. Okay, so V is equals to 3.98 times 10 power of 7. Then if they ask you to calculate the kinetic energy, so just use half mv square or EV, okay, kinetic energy. You see what is the question there? So you got the answer. Because we don't have, if you want to use half mv square pun, I think can, boleh. It's okay because EV is equals to half mv square, right? We already have V here, right? And also we already have, the mass of the electron. Okay, but maybe this one they didn't give, that's why they didn't use this one, half mv square. Okay, in the question they didn't give the mass, they only give the charge. Okay, the charge of an electron is 1.6. Okay, so mean they give you the E, the V. Okay, so that's why we use EV. But if they give you M, okay, you can use this one also. So that is actually depend on the questions. Okay, so kinetic energy EV. Why this one is actually is a electrical energy formula, right? This is the electrical energy formula. So, but why we said that kinetic energy is equals to EV? Because from this equation, so EV is half mv squared. So means the electrical energy is same as the kinetic energy. So if you want to find the kinetic energy, you can find by using the EV also, because we use the principle of conservation of momentum. But like I said, it depends on the stage question, what does it give? And please remember for this one, it's a kilovolt. So you need to change it So 8 times 10 power of 3. Okay, then we just multiply. Okay, this one also, what is the speed? Okay, so this one you want to find V, they give you E, they give you M, so this one you need to use this one, this formula. EV is equals to half mv square. Okay, I will put the notes inside the group class thing. Okay, you can see that. Okay, for the tutorial, I will discuss next week on Saturday. Okay, then after that, we go to 5.2. Okay, so is there any questions you want to ask? Is there any questions? No. Okay, so if no questions, then I will stop here. So I see you next week. No, next week. Tomorrow. Okay, so thank you everyone. Take care. Bye. Bye.